Samuel has a reducing balance loan, and they've shown you 4 lines of the amortization table with some blanks in it. Interest is calculated monthly, and he makes monthly payments of 1,600. Now, using the values in the amortization table, calculate the principal reduction associated with 3. So we know that the interest plus this interest plus the principal reduction should be equal to the regular payment, because when you make repayments, your repayment first goes towards the interest that's calculated, which is a percentage of the previous balance, and then the remaining, which is called principal reduction, goes towards reducing your outstanding balance. So the interest plus your principal reduction is equal to your regular payments. Now, so the first calculation would be 1,600, take away 956.15, and that should give you 643.85. The next question says, calculate the balance of the loan after payment 4 is made. Now payment 4 has, so this is the question. Now payment 4 has 2 blanks, so it's obviously going to be 2 steps. The very first calculation is the interest that you are going to be paying on the outstanding balance of this value. So your interest with respect to your 4th payment is going to be 3.6, which is my annual rate of interest, divided by the number of times, so it's 12, P times 100, okay, times the previous balance, okay, this one. And that works out to be 954.22269. Approximately, if they had asked you, you would have round it up to 2 decimal places. Now the balance is the previous outstanding balance minus the interest, which is this is your principal reduction, and that gives you this value, which rounded to the nearest cent is that. Part B says, let Sn be the balance of Samuel's loan after n months. Write a recurrence rule in terms of S0, Sn plus 1, and Sn that could be used to model the month-to-month balance of the loan. So they want a recurrence relation which has a starting value. So that's the initial balance, that outstanding balance that we had, and that's this. And then the next balance, Sn plus 1, is R. So if you remember the rule is actually V0 is equal to Vn plus 1 is equal to R times Vn minus the repayment. So all they've done is asked you to replace S0 in the place of V and S in the place of all the V's, and then you get your recurrence relation. Your R value here is 1 plus R over 12 times 100, because it's on a monthly repayment basis, and that gives you this value. Please don't write it like this. That's okay when you calculate, but your answer to get the mark for is that one, and you got to replace in these 3 places. Okay, 1,600 has been given to you anyway as your repayments, regular repayments. The next question, it's not too clear, but if you have your paper in front of you, I think you can follow. Samuel opens a savings account. The balance of the savings account n months after it was opened is, so this is the month-to-month value, and because it's a savings account, clearly you can see over here that if you had a Vn plus 1 is equal to R times Vn, this tells you that it's a compound interest question and it's a geometric growth. So that 1.003 is equal to 1 plus R over because it's monthly, its normal formula is P times 100, where P is equal to 12. So if they want the balance after 4 months, so here it's directly after a certain number of months. And if you remember that formula, Vn is equal to Vn plus 1 is equal to R times Vn. So here R to the power of n V0, sorry. So if you were to apply that formula here, it will be B4 is equal to R power 4 B0. And that is this one, and which gives you this answer. Calculate the monthly rate of interest. Now the monthly rate of interest is the annual rate of interest divided by 12. Now as I told you previously, this is actually, because this can be written as 1 plus 0.003. So R over 1200 is equal to this part. So you can actually say R is equal to 0.003 times 1200, which usually gets you the mark if it's a show that question, and gives you 3.6, and that divided by 12 will give me 0.3%. After 1 year, the balance of Samuel's savings account is 5,183. If Samuel had deposited an additional 50 at the end of each month instead, after the interest was added, how much extra money? Extra usually means a difference between two values, okay? After 1 year would be in the savings account. So that's because it's on a monthly basis that he's adding, they're talking about 12 months. Now in this scenario, there are actually two situations. One where he did not add 50 and the other where he did add 50. And so here they've already told you that his balance at the end of 1 year is 5,183. So you have to calculate what his balance would have been if he had added $50 at the end of each month. And you can do that on the sequence tab by just putting in an plus 1 is equal to R times, this is 1.003, an plus 50, and a naught being your starting value of 5,000, and you would get a value after 12 months, which will be 5,793. So the difference in 1 year, if you had not put in $50, and this is when you did put in $50, sorry, this is the value if you had not put in, and this is the value when you did put in, and the difference between them is 610, which is the extra money that you would have got. In question 10, Samuel invests 500,000 into an annuity. So into an annuity means that he is putting in money and he gets regular payments, okay, from it. So the balance after n months, an, can be modeled by a recurrence rule. So there's two parts, a starting value and a rule. Now clearly you can see over here that this obviously is an R value, capital R. Because it's monthly, it must be 1 plus R over 12 times 100. So calculate the balance after 2 months when K is given to you here. So all you have to do is put it into the sequence tab and calculate at the end of 2 months, okay? You have to be careful that you put start is 0, okay? If your start is not 0, showing the money that you deposited, and your end can be anything, but you can read the one after 2 months. Now what I saw on my calculator was 2 had a value that looked like this given. So this is nothing but 5 times 10 to the power of 5. But that's actually not the real value. Now before you record values from your sequence tab, Okay, you should tap it and read the answer that appears at the bottom of your screen. And that answer is actually 498,398.08. Okay, you got to round it off to 2 decimal places and write. Your calculator tends to round it off, but that's not the accepted answer. The answer that you will get the mark for is this one. So you tap it and read it and then write the answer. Okay, calculate the annual compound rate percentage if K is given to be this. So as I explained in the previous question, this can be written as 1 plus 0.0024, and this is equal to that. So your R value is nothing but 1200 times that, which is equal to this calculation, which gives you 2.88% as your annual rate per annum. Okay. For what value of K would it act like a perpetuity? Now, what's the concept of perpetuity? The money that you put in is the money that you take out. It doesn't add, it doesn't increase or decrease in value. So if the K value is the question, you have to calculate the rate, and that rate you have to calculate R using that rate as 1 plus R over 1200. Now, in order to calculate R, you can use the financial solver. Now, because the question said 2 months, okay, you can put 2 over here, leave this blank. Your principal value, because you're investing, is going to be a minus, money is leaving your hand. Your payment, that regular payment that you're getting, is 2000, and it should be a plus because money is coming towards you. Okay, so when money leaves you, it's minus. When money comes to you, it's plus. Now, the future value, you're going to get back this money because it's a perpetuity. It perpetually stayed the same. That's the meaning of perpetuity. And it's got to be a plus because it's going to come back to you. Okay. And PY, payments per year and compounds per year, is 12 because it's monthly. And when you tap on interest, you should get 4.8. Now, as I explained to you, you replace for R is equal to 4.8 in a calculation, and you get K is equal to 1.004. Now, in question 11, Samuel took a new reducing balance loan. So it's now changing. The interest for this loan was 4.1% compounding monthly. The balance of the loan after 4 years was this, and the balance of the loan after 7 years was this. Samuel will continue to make a monthly repayment to ensure the loan is fully repaid. Now, fully repaid means future value is 0. To the nearest cent, the required final repayment will be smaller. In the first 7 years, he made 82 monthly repayments. From this point on, how many more monthly repayments will he need to make to fully repay the loan? Now, in this question, you have to actually use this piece of information that's given. The difference between 4 and 7 years is 3 years. And if you take this to be your PV and this to be your FV and that to be your I, this to be your PYCY, 12, okay. The balance of the loan, because it's a loan, this is money that is still with him, so this will be plus PV. And this actually, the balance after 7 years, okay, is 280,875, is money that he should still repay, so that will be minus. And so when you put that into so if you look at all this information, the one thing that we don't have is his monthly repayment. Okay, so if he had taken this loan for the full period of time, okay, what were his monthly repayments? that caused his loan from this value to reduce to that value. So that's going to be your first calculation. So that's the 3 years in between. 4.1 was the interest. As I told you, this is the loan he got. Okay, that was his repayment, so it's minus. And so this is the loan that is still with him. That's the balance after 3 years. And this is the balance after 5 years, which is minus because he still owes the loan. And then PYCY is 12. And when you tap on PMT, you get the value minus 2,400 and 0.4014. Now, this works out to be minus because it's a repayment. And money leaves you in repayments. Okay? So now what you have to calculate is how many more repayments should he make, okay, in order to fully pay off the loan. So the fully pay off the loan gives you FV of 0. Now, how many more repayments was the blank? I is still 4.1, but the last balance at the end of 5 years, okay, is a starting value, principal value that is still with him now. Be extremely careful. This future value was negative, okay, because in this scenario, in the first scenario, he still owes that loan. But when you're calculating how many more payments he has to make, that balance at the end of 5 years becomes positive because that is still a loan that is with him. Okay, he has the loan. And the payments now we calculated to be this value. Repayments are negative in a reducing balance loan, and the rest future value is 0 to fully pay off the loan. Okay, fully pay off the loan. And PYCY is 12 because all this transaction is happening on a monthly basis. And when we tap on N, we get 149.69533318. You could ask, hey, should I show that? Now, if this is going to be your working for the question, yes, you should show that. And if they've given you a CAS emulator on which you need to write, yes, you have to show all the number of what you see on your calculator, and then round it off to the answer that you want. And that is 150 more monthly payments. Hope you've enjoyed that video and enjoyed learning too. Thank you.